Wir kommen zum nächsten Programmpunkt und ich würde für die Ankündigung unserer nächsten Sprecherin, Karen Yeung, ganz kurz ins Englische switchen, weil Frau Yeung kein Deutsch spricht. Karen, I'm going to briefly switch into English for the introduction, if you don't mind, unless you want to practice your German. So it's a pleasure to have you here with us. Thank you so much for making the effort. Professor Karen Yeung is a chair in law at the Dixon Poon School of Law at King's College London, and she is director of the Center for Technology, Ethics and Law in Society. Professor Yeung is an expert, a leading scholar in the field of regulatory governance studies, which put in simple terms means that you think or study the design and workings of all kinds of instruments that can be used to shape control systems and shape human behavior, which also explains your research interest in new and emerging technologies in general and algorithms in particular. So today, Karen is going to talk about governance systems that use algorithmic decision-making, and she will also highlight some of the democratic and ethical and legal implications, of course. Thank you very much.
So thank you very much for that introduction. I'm just waiting for my slides to come up on the screen. Also, thank you for introducing me in English, and I'm really sorry that I cannot speak German. I didn't realize when I was coming that the whole conference would be in German, but it was particularly kind of recent to introduce me in English because I was in Korea last week and I was introduced in Korean, and my host said a few things that would have embarrassed me, and everyone laughed, and I had no idea what was being said, so fortunately I let the comment pass. Anyway, here are my slides. Let me get started. As you will see, I'm going to speak today about regulation and social ordering through algorithmic decision-making. So in order to start off this story, I guess I need to get the slides to work for a start, but I will just use this. There we go. And the story really begins with the early computers. So this is the first kind of computer back in the 1940s and 50s. And I'm sure that that gentleman there standing in front of that computer had no idea where we would be today. So we move through to the 1980s, and we start to bring these computers into our homes. And that seems quite revolutionary, but it's nothing compared to where we are today. So just to get here from London, I encountered a number of computational systems, and these are only the consumer-facing ones. And I'm sure that you are all familiar with many of these scenes. And this is just to get to the hotel, and of course, the first question is, what's the Wi-Fi code? Anyway, here I am, and I want to ask today questions about what does this all mean for us? So what are the implications of the fact that now almost everything has been touched by computing devices? We see them everywhere, and we encounter them in almost everything we do in daily life. And I guess the reality is that all of these computers are collecting data, behavioral data, all of the time about us and about everything that moves. It is being generated and updated, collected across a population, stored in the cloud, subject to algorithmic processing, and then something happens. And that's the something that I'm interested in and have been interested in recent years. All of this is going to parade under the rubric of big data for the purposes of my talk today. And what I've been interested in is trying to get a grip on what are the implications of these technologies at the societal level. So just to give you a little outline of what I'm going to do today in my talk, I'm going to talk about what is algorithmic regulation. And to do that, I need to talk a little bit about big data, what it is, and why are people so excited about it, or some people so excited about it. How do we understand the logic of algorithmic regulation? And how can identifying different forms of algorithmic regulation help us to identify what is it that's genuinely new about these technological developments? What's actually new and novel about algorithmic regulation? Having explored the logics of these systems, I'm then going to enter into a little bit of a critique of these systems, looking at questions of politics and ideology, the economic drivers, some of the legal, constitutional, and democratic concerns, before bringing my talk to an end with a call to a political and a legal response. So let me begin then with the concept of big data. So I'm sure you'll have heard the the rhetoric that we are standing on the cusp of a new industrial revolution. It's become fashionable to refer to this as the fourth industrial revolution, powered by the engine of big data. And we see that all around us, that almost every service that you can think of has been transformed by these technologies, from finance, retailing, education, health, policing, transportation, energy distribution, dating, mating, etc., you name it. We see that all of these services have been transformed by the various ways in which industry has been harnessing personal digital data in order to generate economic value. But what do we mean when we use this term big data? So there isn't really a universal definition, but essentially it's a combination of a technology and a process. So the technology refers to a configuration of information processing hardware and software that's capable of sifting and sorting and interrogating enormous quantities of data in very short times. The process involves mining that data for patterns, distilling those patterns into predictive analytics, and then applying the analytics to new data. So in essence, it's a methodological technique that utilizes analytic software to identify patterns and correlations through the use of machine learning algorithms applied to often unstructured data sets, collected across a stream of different sources, and converts these data flows into a highly data-intensive form of knowledge. So what's the big deal? Why is there so much excitement about big data? Well, basically, it's because it enables us to discover useful correlations or patterns in data sets that we couldn't see on our own. So these are finding patterns in the data that are not capable of analysis by ordinary human assessment or even conventional computing techniques. And so big data's value lies in finding these patterns that can be derived by making connections about pieces of data. So as Boyd and Crawford say, big data is important because it refers to an analytic phenomenon playing out in academia and industry. They said that in 2012. Since then, it's been playing out in many other places besides. So I'm going to refer to big data as the socio-technical ensemble that utilizes this methodological technique that is critically dependent upon two things. Firstly, massive digital data sets, and secondly, the application of algorithms to find these patterns and correlations, often with the aim of generating actionable insight. So, I guess at base, it's exciting because it is created a method for finding new knowledge. It is a new form of knowledge production, and that is why there is so much excitement. It's being rapidly taken up in many domains besides commerce, academia, government, humanitarian relief, and so on. And there are many potential benefits. It offers tremendous potential to enhance the quality and efficiency of decision-making, particularly in the coordination and control of social action more generally, and which I describe as regulatory governance, which I will talk about a little bit more shortly. So in fact, in the academic literature, there is a large and rapidly growing literature concerned with critical algorithm studies, or sometimes referred to as critical data studies. And in my own work, I have been exploring this phenomenon through the lens of regulatory governance scholarship, although I should say I am a lawyer, but I'm a slightly odd lawyer because I'm interested in some of the social science things that go on around the law, framed around the concept of algorithmic regulation. So what do I mean by this? Well, when you start researching a term, what do? You look on Wikipedia, and Wikipedia says that algorithmic regulation, don't tell my students that, was a term coined by Silicon Valley tech entrepreneur Tim O'Reilly, who describes it as an alternative form of government. And he's quoted in Wikipedia as saying, algorithmic regulation is supposed to be, I like the supposed to be, a system of governance where more exact data collected from citizens via their smart devices and computers is used for more efficiency and in organizing human life as a collective. So that's not bad as a definition. In another paper, in a set of essays, he gives a list of various systems which he thinks are examples of algorithmic regulation, which gives us an idea about what he's talking about, but it's not really precise enough for academic inquiry. So I'm going to offer a slightly more rigorous definition and suggest that algorithmic regulation refers to regulatory governance systems that utilize algorithmic decision-making. Okay, so I need to unpack some of those terms. So what do I mean by regulation? So here I'm drawing on the definition of leading regulatory scholar Julia Black, who defines regulation as intentional attempts to manage risk or alter behavior in order to achieve some pre-specified goal. So it's a very broad and really rather simple definition. And you'll notice here that there's no reference to something that government does. So although we typically think of regulation as something undertaken by governments, it's not confined to governments, and it's also pursued by non-state actors and entities alike. The size of the regulated population that we might be interested in is highly variable. So it might range from a single person who uses a fitness tracker to monitor how many steps they're taking in a day, through to platforms that seek to coordinate and influence the behavior of huge numbers of people, like the Uber ride-sharing platform, for example. So although there are a number of differences between all of these different regulatory systems, the common point is that they are all concerned with trying to achieve some pre-specified goal. So it's an intentional activity, and it's essentially a form of systematic control that is intentionally aimed at addressing a collective problem. So any regulatory system must have some kind of director or regulator who determines what the overarching goal of the regulatory system is. What do I mean by algorithm? Well, I could go on about the various meanings of algorithm, but I don't have time for the purposes of my talk today. So I'm just going to explain that I will adopt a social scientific understanding of algorithms. And so I'm concerned with not just the mathematical formula, but the larger socio-technical assemblage that includes not just the software algorithm, but also the computational networks in which they function, the people who design and implement them, the data, the users on whom they act, the institutions that are providing the services, all connected to a broader social endeavour aimed at knowledge production. And this I describe as an algorithmic system, which enables me to produce a working definition, which is set out on this slide. So, algorithmic regulation refers to decision-making systems that regulate a domain of activity in order to manage risk or alter behaviour through continual computational generation of knowledge from data emitted and directly collected, typically in real time on a continuous basis, from numerous dynamic components pertaining to the regulated environment in order to identify and, if necessary, automatically refine or prompt refinement of the system's operations in order to achieve the overarching goal. You can tell I'm an academic. Hey, that's a terribly academic definition, but it's nice and precise. Okay, so how do we understand what's going on with these systems? How do we understand the logic and the mechanics of them? Well, I'm going to suggest that a helpful way of thinking about these systems is to draw on the theory of cybernetics, which is an interdisciplinary area of inquiry that emerged after the Second World War, which sought to move away from linear understandings of cause and effect relationships towards investigating control through circular causality and feedback. And on a cybernetic account, any control system, if you think about it, from your central heating through to Uber's ride-sharing platform, must have three core components. It must have some set of standards, some standard setting mechanism. It must have a way of monitoring information to try and identify what is going on in the regulated domain. And then it must have a mechanism for enforcing those standards. So if a deviation from the standard is identified, then there must be a mechanism for trying to pull that behavior in line with the desired standards. So if we think about those three different components of a control system, one way of thinking about algorithmic regulation is to identify two alternative configurations of each of those components. So at the level of standards, we could have a very simple behavioral standard, like your password protection system. So the standard is fixed, you have to enter your password correctly, and if you don't, then you can't get into the site. Or the standard might be variable, that is the behavioral standard. So in a smart transportation scheme, there's no fixed speed limit. It will change depending upon what is going on in the environment at any particular time. So it's designed to vary the speeds at which cars can drive and the cycles of traffic lights, because the aim is to optimize traffic flow within the system. And so the standards of behavior within that system will vary depending upon achievement of the optimizing goal. At the level of monitoring, the information that is monitored may be historic data collected about what is actually going on that has been observed, or it may be based on inferred data. So it might take real-time data and historic data and seek to infer predictions about the future based on that data. And it's based on those predictions that the system will act. So we'll see one of those shortly, but a nice example, of course, is your Amazon product recommendation system, which is showing you all the products that you might be interested in based upon your shopping history, your browsing history, and that of everybody else, to predict the things that you are likely to be interested in, which, of course, is going to make Amazon more money. At the level of enforcement, then the output of the system might be a recommender system, like your Amazon shopping recommendation system. So Amazon doesn't automatically buy these products for you, thank God. It's up to you. You still have control. You can still exercise your discretion in deciding which of those items of data that have been given the highest relevance to you, you actually want to purchase or not. Or the mechanism for enforcement might be automated. So for your password protection system, you get that wrong, you can't get into the website. It just happens, the axe comes down, thank you for playing. Okay, so there's no discretion in the way in which that system works. So this actually, by thinking about these different forms of algorithmic regulation, we can help to identify what is it that's genuinely novel about these two systems. And for this purpose, I want to distinguish between, broadly speaking, reactive systems that collect historic data and they trigger response based on historic data. So your kind of speed camera and issuing fine system is a classic system that's based on historic data. So you don't get the ticket until after you've committed a speeding violation, at least for the time being, right? For the time being, you only get the ticket once the camera has observed that you have exceeded the speed limit and it issues a ticket accordingly because it can recognize your car. So that's a reactive system. What is more exciting is the fact that we can preempt what you are about to do next. And it's these systems that are genuinely novel, okay? Because they act preemptively by basically algorithmically mining all of this data to predict or infer likely future behavior, and on that basis to trigger a response in order to shape your future action. So that's why they're particularly important, and these two forms roughly track two important developments in the computerization of regulatory governance systems, which help to identify what it is that's genuinely new about this form of regulation. So the two things that are going on here, and which I think are helpful to distinguish, is on the one hand the turn to automation, which we see widespread and growing, and secondly, the use of artificial intelligence. And I think it's really helpful to keep these two things distinct conceptually in our mind, because one of them is really novel, the other one is not. So let me say first something about automation, and these are the reactive systems that I'm talking about. And it seems now that the rise of computing and all of these digital sensors makes it possible to automate many control systems that we wouldn't previously have contemplated automating, like these digital password protection systems. But you see here something that looks really rather novel, and it turns out that, in fact, this is a facial recognition toilet paper dispenser in public lavatories in China. Okay, so the aim here is to stop people taking the toilet roll away, okay? So to try and stop that from happening, once upon a time you had to put a little attendant in the public toilet, but the trouble with that, it's very expensive, and presumably the toilet attendant is corruptible. But apart from that, now you go into a public lavatory in China, and you have to stand in front of it, it recognizes your face, and you get exactly 6 sheets of toilet paper. Okay? If you want more, you have to wait 7 minutes, and then you can get another 6 sheets. Okay? But don't you love the way there's a little one here for children? There's a little one for children, so they get those 6 sheets of toilet paper too. Now, this looks like it's really innovative and fresh, but in fact, the underlying logic can be traced back 3,000 years to the invention of the water lock. It is just a simple, fully automated control system, which means that you don't need a human to issue the sanction. All right, it operates in a completely fixed loop where you don't need human intervention. So that's full automation. And the reason why that's worth studying is not because the logic is new, but because it has become so cheap to install these systems that they are proliferating everywhere. Even 10 years ago, you just wouldn't have contemplated doing that. It would have been far too expensive. But now, China have them in the public laboratories. On the other hand, the other thing that has become important is genuinely new, and that is the rise of artificial intelligence. And so here I'm referring to the application of machine learning techniques applied to data collected from these ubiquitous digital devices, which allows continuous behavioral tracking, and this enables smart forms of algorithmic regulation. Not only that, it's particularly powerful because it can reach across an entire population. In fact, Facebook reaches across more than a national population, and it reaches across a global population. And so it makes it vastly more powerful than traditional forms of architectural regulation by enabling the tracking intervention in the behavior of an entire population of users across a widely geographically dispersed area in real time. So in many ways, if you think of the way in which we've used architecture in the past to shape behavior, they've been fairly limited in their reach. So think about a speed hump. It's very effective in slowing cars down, but it only slows one car down at a time in that particular location. Compare that to Facebook's newsfeed. Many, many orders of magnitude more powerful than your simple speed hump. And at the same time, these algorithmic systems now have a predictive capacity, which enables the prediction of not just individual behavior, but whole population-wide trends that can reveal and automatically act upon the hidden insight which these systems generate. And it's this capacity to predict future action, and so to intervene and act upon it, that is considered to be the holy grail of big data. So how do we make sense of the underlying logic that's going on here? Well, in the paper that I'll give you the citation to, I talk about the various logics that we can find in sort of analog systems of regulatory governance control systems. And we can see this kind of logic that is evident in these algorithmic systems. So there's outcome-based regulation, data-driven performance management, risk-based regulation, actuarial justice, surveillance-driven social sorting. I won't talk about them now. But all of these logics are evident in algorithmic regulation, but they have a number of advantages over these old analog systems. So firstly, you can remove the human in the loop. You can remove human oversight by replacing them with ubiquitous digital networked sensors. And this enables monitoring of performance continuously against targets at greatly reduced cost and human effort. That these systems, unlike analog systems, operate dynamically, continuously fed by real-time data. And so this allows almost immediate intervention to direct or constrain the targeted behavior. And this avoids the problems of out-of-date performance data. And finally, part of the allure of algorithmic systems is that they appear to be based on objective, verifiable evidence, because knowledge of system performance is based on data that's collected directly from the environment, from a multitude of behavioral sensors, and this holds out the prospect of game-proof design. Now, all of these claims warrant further scrutiny and I don't think stand up very well. But I won't examine them right at this point because I want to suggest a way of thinking about these systems that I think is rather fruitful. And that is to suggest that perhaps all of these systems can be understood as resting on a common form of social ordering called algorithmic regulation or algocracy. And so although Tim O'Reilly is credited with the term, in fact it was a sociologist who came up with the term back in 2009 in his ethnographic study of the labour practice of offshoring. So he was interested in understanding how is it that workers in India can provide IT services to US firms and for this to work effectively. So in his study, he identified software programming schedules as absolutely critical to this enterprise, to the organisation of globally dispersed labour. And so he identifies algocracy as a system of governance which he says is based on the rule of the algorithm. And more importantly, the reason why this is significant is that it's different from familiar systems of social ordering. So it's different from bureaucratic hierarchy, as well as being different from market-driven forms of governance, because the underlying logic is driven by the algorithm, which ultimately is mathematical. So for me, I think understanding algorithms as a distinct form of social ordering is an enormously fruitful perspective to ground critical examination. And so having looked at the underlying logic of these systems, I now want to move on to thinking a bit more critically about what the implications are for society. So I'm going to talk a little bit about the politics and drivers, the rise of algorithmic power, some legal and constitutional concerns, and the rise of the new surveillance in my remaining 10 minutes, 5 minutes. Okay, so this is where it gets interesting. So what are the politics of this? If we think about markets and we think about bureaucratic hierarchy, each of these forms of social ordering is typically associated with a particular ideology or a particular politics. But what about algorithmic forms of social ordering? What is the ideology and the politics of this particular way of coordinating social action? Well, I'm going to start here with some claims by historian Yuval Harari, whose book you may have read, Homo Deus. He, in that book, coined the term dataism. And for Harari, dataism is an emerging religion rooted in a belief that humans simply can't distill the immense flows of data into information, knowledge, or wisdom. We can't make sense of all that data. And so we must trust the work of processing that data to computational algorithms whose capacity to process data far exceeds that of our own. So for him, dataism transcends political ideology, and therefore free market capitalism and state-controlled communism can simply be understood as merely competing data processing systems. Well, who knew? For him, capitalism is just distributed processing, which directly connects producers and consumers to one another so that they can exchange information freely and make their own decisions, whilst communism is a form of centralized processing. Well, I find this a problematic assertion because it assumes that political systems are only concerned with optimally distributing society's material resources, and it crudely overlooks the underlying politics, values, and normative premises underlying different political systems. So having said that, algorithmic systems have been, in fact, associated with two dramatically opposed political visions by these two men. So on the one hand, you have Tim O'Reilly from Silicon Valley, who sees algorithmic regulation as seamless, fully automated, data-driven governance that will solve social coordination problems with the efficiency of a Google search engine. On the other hand, we have Evgeny Morozov, who seeks to expose what he believes is the hidden anti-democratic vision of Silicon Valley's belief that technological innovation can solve social problems efficiently simply by harnessing the power of the internet. So he is very suspicious of the claims of Silicon Valley, and I want to spend a little bit of time unpacking his critique. So Morozov's observations spring from recognizing that the means or the instruments through which we seek to govern have inescapable political and ideological dimensions, and that inevitably shape our substantive political goals. But the problem with algorithms is that these are hidden. So unlike earlier debates about whether we should pursue some kind of social solution via the state or via the market, the ideological dimensions of algorithms are much more difficult to discern. Nevertheless, he suggests that the underlying ideology here is that of solutionism. So for Morozov, solutionism is characterized by four components. Firstly, govern effects, not causes. In other words, treat the symptoms, don't treat the cause of the problem. And this is a logic that he identifies in the work of Italian philosopher Giorgio Agamben. Secondly, expand oversight and collect as much data as you can. So this is not a vision of the small libertarian state. Thirdly, encourage individuals to take responsibility for their own problems, for their health, for their safety, for their productivity, by giving them smart tracking devices. And he points out that, so for example, if you want to get a discount on your car insurance, you can agree to have a monitoring device in your car and you'll get a discount. He says, at the moment, these are perceived as optional. He said, but in future, they might be compulsory, or if you don't accept one, you'll be seen as a deviant and your premiums will be much higher, and you might even be excluded. Finally, let's characterize individuals as entrepreneurs and the sharing economy as the new welfare state. So we're all just stockholders in some giant enterprise, empowered to take care of our own affairs via these ubiquitous feedback loops. And there aren't social problems that require collective solutions. We can just handle them as individuals acting on our own. Well, if we take this ideology and we think about what's going on in the economic realm, and it's very clear that our economics is so very driven by the forces of global capitalism, that if we combine capitalism with this solutionist mindset, we end up with what Shoshana Zuboff calls a new form of information capitalism, which she dubs surveillance capitalism. So she says that driven by Silicon Valley's hyperscale technology companies, of which Google is the #1, these firms achieve growth primarily by leveraging automation on global digital platforms. So this is the logic of the new surveillance that Zuboff points out. She says revenues now depend upon data assets appropriated through these ubiquitous automated operations, and it's this data that forms a new asset class, which she refers to as surveillance assets. This generates a new default business model where company valuations are routinely dependent upon eyeballs rather than revenue as a predictor of profitability. And this model channels and controls flows of personal information while converting them to flows of profit, all of which happens in ways that are highly opaque to the users. Well, she is very pessimistic about the implications of the rise of surveillance capitalism. And one of the things that's worth noting is that this entire business model relies critically on highly granular, population-wide, continuously updated mass surveillance. It's become unfashionable to use the word surveillance. We use instead the word tracking, but let's be honest about it, it's just surveillance, which industrialized societies increasingly rely upon. But maybe the reason why we use the term tracking is, unlike the old forms of surveillance, the kinds of surveillance that Orwell warned about in his Big Brother, we see a distinctly Western democratic type of surveillance society emerging, in which we willingly allow ourselves to be surveilled, and we give up our personal data in exchange for these fantastic, incredibly efficient and convenient digital tools. And the reason why this is legally acceptable is because it rests on a model of privacy self-management, or it's the notice and consent model, which legal scholars have trenchantly criticized as inadequate in a big data environment because it's practically impossible to provide real, meaningful consent to the data sharing activities that are now going on in the complex ecosystem that has now emerged, that has been entailed by these algorithmic systems. Well, this logic that we give up our personal data in return for efficiency and convenience is not just happening at the individual level, it's also happening at the collective level. Evidenced, for example, by the decision of 3 London hospitals earlier in the year to give up 1.6 million British patient records to Google DeepMind without their consent, because Google offered to provide healthcare analytics to the hospitals pro bono. This was later found to be unlawful, but nevertheless, this is what is going on. And so it seems to me that our consent to this exchange isn't really consent. It's a bit like the consent of the addict, like the compulsive gambler, who finds it impossible to kick the habit, despite its long-term costs, because we just can't get enough of it. It just tastes so good. For Zuboff, this is a Faustian pact. For Davidow, he observes that millions of people are now virtually incarcerated in algorithmic prisons, unable to find employment. They have difficulty accessing various services, including insurance, loan financing, houses to rent, properties to purchase, or even to board an aeroplane because of their internet profiles. Well, legal scholars have also warned about some of the implications of the algorithmic turn for a number of legal and constitutional values and fundamental rights. So there are real worries about how these processes are affecting transparency and accountability because they're highly opaque and almost impossible for the lay user to understand. Most people don't even know they're going on, and even if they did, they wouldn't be able to identify what kind of behavior condemned them in the first place. It threatens a number of fundamental rights, most notably the right to informational privacy, but it threatens individual autonomy and self-determination more generally. It also often is the case that you have no right to contest a decision that has been made by an algorithm. The computer says no, thank you for playing. And this contradicts our commitment to due process, to giving people a right to challenge and to appeal against decisions. And of course, I'm sure you're aware that a number of concerns have been raised about the discriminatory effects of these algorithms and the principle of equality of treatment, noticing how these systems, because they rely on historic data, can simply replicate historic patterns of bias against social groups that have historically been marginalised. So recognising all of these concerns has fueled demand for mechanisms of algorithmic accountability, calling for mechanisms through which algorithmic decisions can be explained and justified to those affected against some criteria and to make amends for any fault or error. The need for explainability is particularly acute. At least for liberal democratic societies, it's acute because we aspire to be transparent orders where the working of our society and all of its mechanisms can be known and available for public scrutiny and apprehension. Concerns therefore arise about not just individual privacy, but the risks to collective values of transparency and accountability. And my worry is that a wholesale shift in favour of these systems threatens to erode the collective moral and cultural fabric upon which democracy and individual freedom rests. So it's tempting to think of privacy as an individual right. So if it's mine, I can give it up. I can consent to Google having all of my data. And in a sense, that's true, but it's not far enough because privacy is not just an individual good, it is a collective good. It is the zone of protection around each individual's activities in a society that makes it possible for an individual to flourish, to explore their own identity and their own sense of self, in which our individuality can emerge, mutate, and stabilise. And with it, without that zone of protection, there is no democratic or individual freedom. And I'm sure if you've seen the circle, you will understand what I mean by that. And yet this collective nature of this moral and social infrastructure is frequently overlooked in contemporary debate. So if there's one take-home you get from my talk, please let it be that. So what do we do about this? If we're troubled by it, and I think we should be, we don't necessarily have to be as pessimistic as Shoshana Zuboff to accept that there is something important going on and a very rich set of increasingly urgent questions that the turn to algorithmic regulation evokes. There are many analytical and disciplinary lenses that we could adopt for trying to interrogate it in order to respond to the calls for algorithmic accountability. But to understand what this might require, I think we need a deeper understanding of algorithmic power, processes, contexts, and drivers. And one of the important features of what we see going on now is that there are deep power asymmetries in the way in which these emerging algorithmic systems are designed and are implemented. And even the World Economic Forum, which is one of the greatest champions of new technology, has recognized that in these emerging technological systems, individuals lack real power. They are largely passive data subjects who lack meaningful influence and control over the disposition and use of their personal data. So what do we do? I think the answer must lie in the political realm. So there are real concerns at the level of global governance that we have to be attentive to what is going on and to recognize that all technologies have politics. This is an extract from the handbook, still in draft, not yet published. And in it, there are acknowledged recognition that technology is political. And by this, they mean that technologies contain within them a whole set of assumptions, values, and principles that in turn can and do affect power, structure and status in society. And so once we understand that technology embodies politics, then that gives us greater power to initiate change. It obliges us to take responsibility. We can't just say, oh, that's just the technology doing its own thing. We have responsibilities to understand, and we have the capacity to influence how they are developed. And so accepting this means coming to terms with 3 responsibilities: to identify the values that are at stake in the use of these technologies, to understand how they impact our choices, and thirdly, to determine how we can influence them through democratic dialogue with appropriate stakeholders. So it closes in the political negotiation between society, technologies, and the economy. Determining the amount of attention given to societal values is up to us. So the answer lies in the political realm, and then from the political realm, possibly in the legal realm. So to conclude then, algorithmic regulation in the form that is currently emerging in contemporary modern democracies is threatening the constitutional balance in liberal democratic orders, because it provides a one-way mirror that allows institutions looking down to surveil those below, but those below don't really have any real prospect of peering into and understanding and challenging the algorithmic black boxes that increasingly regulate their lives. But it need not be like this. These choices are political, albeit driven by economic self-interest. And it is possible in theory to envisage a much more egalitarian, progressive system of algorithmic regulation, whereby not only is your boss monitoring what you're doing, but you are monitoring your boss. Funnily enough, Silicon Valley aren't developing these apps, and that's because there's no money in it. So I suspect that we won't see more egalitarian systems emerging spontaneously from a capitalist order without political intervention. That brings me to the end. If you want more information about my critique, you can find it there, and that's my email address. Thank you very much.